गुड इव्हनिंग सर्वांना. कालपासून आपण युनिट्स अँड मेजरमेंट हा 11वीचा चॅप्टर स्टार्ट केला आहे. आज आपण या ठिकाणी युनिट्स अँड मेजरमेंटचा पुढील पार्ट पाहणार आहोत. तर आजचा जो काही महत्त्वपूर्ण पार्ट आहे त्यामध्ये सप्लिमेंटरी फंडामेंटल क्वांटिटीज अँड देअर युनिट्स हे आपल्याला पाहायचं आहे. सप्लिमेंटरी fundamental quantities and their units. Today we have to see this important point from the chapter first of class 11 units and measurement. See supplementary fundamental quantities and their unit. Here we have to see what is meant by the supplementary fundamental quantities and their units. Radian and steradian are the two supplementary fundamental units. Its measure plane angle and solid angle respectively. वो plane angle और solid angle measurement करने का काम करते हैं. Then we have to see one small table. Here supplementary fundamental quantity, there are two supplementary fundamental quantities. First one is the plane angle, right? First one is the plane angle. Then second one is the solid angle. Yes, solid angle. What is the unit name for the plane angle and solid angle? Radian, right? Radian. And then steradian. Steradian and radian are the units for the plane angle and solid angle. Plane angle unit is radian and solid angle unit is steradian, right? What is the symbol for that unit? Radian symbol is RAD and steradian symbol is SR, steradian, right? Then what is the definition for radian and steradian? We have to see here. Listen. 1 radian is the angle subtended at the center of the circle by an arc equal in length to the radius of the circle, that is d theta is equal to ds by r. What? Once again, please listen. 1 radian is the angle subtended at the center of the circle by an arc equal in the length to the radius of the circle, that is d theta is equal to ds by r. Then what is steradian? Definition of steradian is 1 steradian is the solid angle subtended at the center of the sphere by the surface of the sphere which is equal in area to the square of radius of the sphere, that is d omega. D omega is equal to the dA by r square, right? dA by r square, right? Then after supplementary fundamental quantities and their units, we have to see the derived quantities and their units, right? Derived quantities and their units. Derived quantities and their units, right? We have to see here derived quantities and their units. Listen, what are the derived quantities and their units? Those physical quantities which are derived from the fundamental quantities are called as derived quantities. क्या कहा है यहाँ पर? What is meant by the derived quantities? Those physical quantities which are derived from fundamental quantities are called as the derived quantities, and their units are called as derived units, and their units are called as the derived units. For example, velocity, acceleration, force, work, etc. Right? For example, velocity, acceleration, force, work, etc. Right? Derived from the other physical quantity. Suppose velocity. Velocity is equal. What is the formula for the velocity? Velocity is equal to displacement divided by time. Right? Velocity is equal to displacement divided by time. Right? Then it is derived from displacement and time. We get velocity. Then acceleration is equal to acceleration derived from the velocity divided by time, right? Then force is equal to mass into acceleration, work, force into displacement, right? Then after that we have to see the system of units or systems of units, right? I will erase it. We have to see today systems of units. There are different types of the system of units. We have to see it one by one, right? Listen, see here, systems of units. New point, systems of units, right? What is meant by the systems of unit? And what is the basic about that point, system of units? Listen, a system of units is the complete set of units. System of units is the complete set of units, both fundamental and derived. Both fundamental and derived for all kinds of physical quantity, right? Then the common system of units which is used in the mechanics are given below. Common system of units which is used in the mechanics is given below. There are different types of the system of units used here. First one is the CGS system, right? First one is a CGS system, right? Then FPS system. Then MKS system, right? Then SI system. We know SI system used everywhere in the universe, right? In every nation, SI system internationally accepted. Firstly, we have to see the CGS system, then FPS system, then MKS system, and then SI system. All are the types of the system of units in which we measure the different physical quantities, right? Listen, CGS system. In this system, the unit of length is centimeter, the unit of mass is gram, and the unit of time is second, right? Centimeter, gram, second system. Then foot, pound, second system. Listen, in this system, the unit of length is foot, the unit of mass is pound, and the unit of time is the second, we know generally. Then MKS system, we have to see the MKS system. In this system, the unit of length is meter, then the unit of mass is kilogram, right? Then the unit of time is second. देखिए, foot, pound, second system. Then MKS system, right? In this system, unit of length is meter, the unit of mass is kilogram, and unit of time is second, right? M for mass, right? Yeah, right? No. M for meter, right? M for meter. Then K for kilogram, and S for second. Then SI system. Here in the SI system, we have to see the system of units which is accepted internationally for measurement in the system. International units abbreviated as SI, right? This system contains 7 fundamental units. This system contains 7 fundamental units, right? And 2 supplementary fundamental units. 2 supplementary fundamental units and 7 fundamental units. Then we have to see the relationship between some mechanical SI unit and commonly used units. We have to see after that the relationship between the some mechanical SI unit and complementary used units, right? We have to see it. We will see it one by one. This is the basic chapter for NEET as well as JEE student. All concepts we have to cover one by one, and after that we have to take the numerical as well as MCQ, right? We have to practice different formulae. We have to see the different concepts, right? Listen, relationship between some mechanical totally concentrate here. Relationship between some mechanical SI unit and commonly used units and commonly used units. When I will write on board, see very consciously and read, right? It is also the method of study. Listen every word carefully, right? We have to see the one table. I will write serial number, right? Then physical quantities, then units, right? Units. First one, length, right? First physical quantity we have to see length. Units for the length are micrometer, nanometer, angstrom, right? We have to see one by one. 1, 2, 3. 1 micrometer, then 1 nanometer, then 1 angstrom, we have to convert it in the meter, right? 1 micrometer is equal to 10 raised to minus 6 meter. 1 nanometer is equal to 10 raised to minus 9 meter, and 1 angstrom is equal to 10 raised to minus 10 meter, right? 1 angstrom, that is 1 angstrom unit is equal to 10 raised to minus 10 meter. Then after that we have to see the mass, right? We have to see the second physical quantity, mass, right? Mass. We have to convert 1 metric ton, 1 pound and 1 AMU, right? 1 metric ton, then 1 pound, right? 1 pound, and then 1 AMU. We have to convert all these physical quantity units into the kilogram, right? Here, first, second, and third. 1 metric ton is equal to 10 raised to minus 9 plus 3 kilogram, right? 1 pound is equal to 0.4537 kilogram, and then 1 AMU is equal to 1.66 into 10 raised to minus 23 kilogram. Put it in your mind. 1 metric ton is equal to 10 raised to 3 kilogram. 1 pound is equal to 0.4537 kilogram, and 1 atomic mass unit is equal to 1.66 into 10 raised to minus 23 kilogram, right? Then we have to see volume, right? We have to see the volume. 1 dyne and 1 kgf. Convert it. 1 dyne is equal to 10 raised to minus 5 Newton and 1 kgf is equal to 9.81 Newton. Right? Then we have to see the force. Right? The fourth physical quantity is force. Force. Listen, here force unit is dyne, right? Then 1 dyne is equal to 10 raised to minus 5 Newton. Newton is also the unit of force. Then 1 kgf is equal to 9.81 Newton. Then we have to see the conversion of volume unit, right? 1 liter is equal to 10 raised to 3 milliliter ml, right? 10 raised to 3 milliliter, right? Then we have to see one another conversion. 1 liter is equal to 10 raised to minus 3 meter cube. 1 liter is equal to 10 raised to minus 3 meter cube, right? These all are the conversion for the physical quantities, right? Fit it in your mind. So you have to see another physical quantity conversion one by one, right? I will erase it. Every day you have to listen very carefully. You have to read the NCERT textbooks, right? NCERT textbook you have to read, and after that you have to make a notes for the given chapter, right? And after that you have to solve the MCQ. Without reading and without practice you will not get the marks. Even I teach every day, you will not get marks. When you will get good marks? When you listen very carefully in the classroom, then when you read very carefully in your home, and when you will practice the MCQ and numericals. You have to put, you have to fit all the formula conversion in your mind, right? After that we have to see the pressure. Next physical quantity, pressure, right? Conversion for pressure is 1 kg of meter square is equal to 9.81 Newton per meter square, right? Then 1 millimeter of mercury is equal to how much? 133 Newton per meter square. Then 1 Pascal is equal to the 1 Newton per meter square, right? Then 1 atmosphere pressure is equal to 76 centimeter of mercury, and also is equal to the 1.01 into 10 raised to 5 Pascal. Read it carefully, focus on that only. Then we have to see the another two physical quantity, that is the work and energy, right? Work and energy. 1 erg is equal to 10 raised to minus 7 joule, right? Then 1 kilogram kg of meter is equal to 9.81. Then another conversion we have to see 1 kilowatt is equal to 3.6 into 10 raised to 6 joule, right? Then 1 electron volt is equal to 1.6 into 10 raised to minus 19 joule, right? Read it. Then we have to see the last physical quantity, power, right? Power 1 kg of meter per second is equal to 9.81 watt, right? And 1 horsepower power is equal to 746 watt, right? All conversion you have to fit it in your mind and you have to read in your home. Next part, some practical units of length and dimensions. This point we have to see in the tomorrow lecture. Thank you.